Okay, so linear per se, we don't cover linear in grade 11, but we do sometimes end up with like, let's say quadratic and a linear, we want to see where they intersect. Or you're gonna, like the MAP 4C, we do go over some linear stuff, okay? So maybe not in grade 11 per se, because we deal with quadratic mostly in grade 11, but it's good to know the linear stuff. Okay? And there's other stuff that we go over, like isolating and finding the x-intercept, finding the y-intercept. So that's why I would like to go over this review. Okay? I forgot what I want to say there. What did I want to say? So, a linear relation, so there's two ways that I can write a linear relation. I can write it in standard form, or I can write it in y equals mx plus b form, which is this y-intercept slope form, okay? But we're gonna start with the standard form. So our linear relation, which is ax plus by plus c equals 0, is represented by a straight line, okay? So, I know this might kind of sound weird to you guys, okay? But what's a linear relation? A linear relation is when I have a straight line, okay? So if I'm graphing, right, so this is my x and this is my y, right? If I have a straight line, so a line that goes either like this, or let's say a line that goes like this, these are called straight lines, and they are represented by this kind of equation, okay? Where a, b, and c are numbers, okay? Usually a, b, and c supposed to be whole numbers, and a has to be positive as well. So a should be a positive number, and should be a whole number. Okay? So an example would be 2x plus 3y plus 5 equals 0, right? If I look at something like this, I should be able to see that this is a linear function. Okay? So if I draw this, it's going to give me a straight line. Okay? We'll talk about how can we draw this. Okay? I have the x and the y. So do you guys know that this is the y-axis and this is the x-axis? They should be straight line and they should be perpendicular. All right. Now, I'm going to graph a line. Okay? This is a line. Now, can you tell me where is your x-intercept? So where is your red line? That red line is intersecting the x-axis. Right here in the negative? Yeah? So this is called the x-intercept. Okay? Because you see how that red line is intersecting the x-axis. Okay? How about your y-intercept? Yeah? So this is where the y-intercept is. So it's where the red line is intersecting the y-axis. Okay? So the x and y intercept of a linear relation are where the line crosses the x-axis and the y-axis respectively. So let's pretend that this, I'm just going to give you some numbers here. So this is -2 and this is 1. Okay? For the x-intercept point, can you tell me what this x-intercept point is? So if I'm going to write it as a point, can you tell me what this point is? Minus 2. What's the y value of that? 0. Okay, so if you're looking at this point, the x value is negative 2 because it's on the x-axis, and the y value is 0 because if you look at this point here, right, it's on the x-axis, the y value here is 0. Okay? Now, how about this point? How would I write this point right here? What's the x value of this point?
1.
X is 0, and y is 1. So, 0, comma 1. Let me just open another page here. You don't have to write this. This is point A. Can you tell me what this point is? What's the value of this point?
Minus 3,
Mhm.
4.
So a point has x and y value. Okay? So any point has two values. X first, comma, y. Okay? So if I look at this point here, which is A, the x value is at negative 3. And the y value, so I have to put negative 3 comma, and the y value is at 4. Okay?
Had a student that was confused about where they needed to be, they're actually giving you class, it's Frank St.
Deanna? Okay. Now, how about this point here? Let's call it point B. What's the x value? 2, 1, right? So 2, 1. All right. How about this value?
5.
Negative 5,
-3.
negative 3. Okay, so negative 5 on the x, negative 3 on the y. Okay? All right, good. So these are the points. We need to know where to locate them. Okay? Now, what if my point is, so I'm going to pick another color here. Okay? This point here. I'm going to call that point D.
-1.
1 because it's on the x-axis.
-1.
So negative 1, comma,
0.
0. Okay? So if it's on the x-axis, the x is whatever the value is, and the y is 0. Okay? Now what if the point is right here? What is that point? So what's the x value here?
0.
0, because you see it's on the y-axis, so x is 0, and y is 5. Okay? So you need to be able to locate these points. Okay? Are we good with that? to this. So if I'm looking at the x-intercept, I have to set y to 0. So anytime I'm looking at a y-intercept, okay, look here, at the x-intercept, sorry. My x-intercept here, y is 0, right? My x-intercept is here, y is 0. So anytime I'm looking for an x-intercept, I have to set y to 0, okay? So to find the x-intercept, set y equal to 0 and solve for x given the coordinate point x, 0. Okay? So any y-intercept is going to give you, any x-intercept, sorry, it's going to give you a value, comma, 0. Now, to find the y-intercept, what do I have to set equal to 0? X. Because you see, x is 0, y is whatever the value is. Okay? So set x equal to 0 and solve for y, giving coordinate 0, y. To draw the linear relation, plot the x and y intercept and draw a straight line between the 2 points. So that's one way for me to graph a linear relation. Find the x-intercept, find the y-intercept, draw a line. Okay? So look at this. Does this look like ax plus by plus c equals to 0 to you? Right? Ax plus b, there's a 1 here that we don't see. By plus c equals 0, right? That looks like a linear function. Okay. Now, we're going to have to draw this one. To draw it, they want you they want me to find the intercepts. Okay? So first, let's find the x-intercept. So to find the x-intercept, what do I have to do? So let's go back here. To find the x-intercept, I have to set y equal to 0. So set y equal to 0. Okay? So that means I'm going to have to replace y with a 0. So that's going to be 2x plus 0 minus 6 equals 0. Do you see that? We see that? So we replace that y with a 0. Okay, now let's do the math here. So I have 2x plus 0 minus 6. What's 0 minus 6? Negative 6. So I have 2x minus 6 equals 0. Okay. I want to isolate for x. What's the first thing I have to do? Bring the negative 6 over. So 2x equals to 6. Okay. Let me stop here for a second. Who doesn't know what happened at this point? Who knows what happened here?
Substitution.
It's isolation. Yeah. So we did substitution, and then now we're isolating. By 2. Okay? So the first thing, guys, eyes on me, please, on the board. 0 minus 6 gives me negative 6. Okay, are we okay with that point?
Yeah.
I want to see heads nodding down. Yes, 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 yes. Okay, good. Now, I want to leave x by itself. to leave x by itself, I have to get rid of that negative 6. Anytime you move something from one side of the equality to the other side, you do what we call opposite operation. Okay? So the opposite of minus is plus, addition, right? So when I bring that negative 6 over here, it's going to become plus 6. Now 0 plus 6 is 6. That's why I just put 6 down. Yes. Okay? Now, my next step, I still have 2x. I want to get rid of that 2. What's happening between the 2 and the x? Multiplication. If I'm going to bring the 2 over, what's the opposite of multiplication? Division. So what happened here is that it's going to become x equals 6 over 2. Okay? Which gives me 3. So that means x equals to 3. So remember that. Y is 0, x is 3. So what's my point? 3, 0. Perfect. So that's my point. X is 3, y is 0. Okay? So if I'm going to come to this graph and place that on my Cartesian plane. On this line? On the 3. That's right. Because remember that this is x, this is y, right? So x is 3, y is 0, it stays here. Are we okay with that?
You don't have to mark 0?
It's at that point. So you're at 3 and then you're moving nothing.
Okay. Yeah,
So you stay here.
Yeah.
Okay? Now, remember I need 2 points to be able to graph a line. Right? I can't graph a line with only 1 point. So I need to find the y-intercept. What do I set equal to 0? I set x equal to 0. Okay, so remember, my equation is 2x plus y minus 6 equals 0. Now I have to set x equal to 0. So I have 2 times 0 plus y minus 6 equals to 0. Are we okay with that? So you see where my x is? I set it to equal to 0. BEDMAS tells me I have to do my multiplication first, right? So BEDMAS tells me I have to see what 2 times 0 is. 2 times 0 is? 0. I can get rid of it. I don't have to keep it, right? So, now, I have left y minus 6 equal to 0. You want to isolate for your letter. So you want y by itself. What do? Bring the negative 6 over, right? Because you want to isolate for y, you want to leave y by itself. Bring the 6 over. Opposite of subtraction is addition. So it's going to become y equals 6. 6 plus 0 is 6. Okay? So you see that my point here is y equals 6. What's the point then? X is what? 0. Y is 6. So, x is 0, y is 6. So where do I put it? All the way on the top, right? X is 0, so I start at x is 0, and then I have to go up to the 6. So that's going to be right here. So you see now that I have 2 points. I need to join these 2 points to give me my line. Okay? That line extends. It should extend. It should be like it's a straight line. It's a continuous. It doesn't stop here. Right? A line, yes, I have these 2 points that are on the line, but my line extends. So this would be the line that I have with these 2 y-axes. Always put arrows at the end of your lines, that means it keeps going. It doesn't stop. Okay, that's what arrows indicate. Are we okay with this? So this is one way to graph, is to find your x-intercept, to find your y-intercept, put them on the graph, draw your line. Okay? Now,
Yeah, this is done.
it's way too many. The other way that you can graph a line is to make a table of value. And table of value is important because you can graph anything with a table of value. Okay? If you know how to make a table of value, that could be for any function, any equation that you have. Quadratic, linear, exponential, whatever it is, if you know how to make it. So, completing a table of values. So a set of ordered pairs, is it ordered or? Can be determined by completing a table of values for a linear relation. So ordered pairs means x and y, okay? So it means points, same thing, same different vocabulary, same meaning. So here's my equation. Y equals 3x plus 2. This is another form of a linear. How do I know they're linear? Does anyone know?
Because of the equation.
Yes. What makes it specifically linear? There's no exponents. Okay? You see that later on we're going to see that we have something that looks like this. Right? So we start seeing exponents. Okay? In this case, you see that both y and x have nothing on top of them. So we know it's linear. We'll talk more about this later. Okay? So, now, I have the equation y equals 3x plus 2. They want you to create a table of values where x is negative 2, negative 1, 0, 1, 2. Okay? So let me show you. A table of value is going to look like this. You're going to make a t-chart. You're going to put x first because you see how my points x, y. Okay? So you're going to put x first. And then they gave you the x values that they want you to use. Okay? So the x values are negative 2, negative 1, 0, 1, and 2. Okay? Now, the equation is y equals 3x plus 2. Okay? So that's my equation. Y equals 3x plus 2. So what is your y value when x equals negative 2? That's what the question is asking. So I'm going to take the negative 2 and I'm going to replace x with it. So that's going to be y equals 3 times negative 2 plus 2. You see what happened?
Yeah.
Do you understand where I got the x values from? Right? They gave me that x should be negative 2, negative 1, 0, 1, and 2. So they gave me these x values. Now what I'm doing is I'm trying to find the y value. So what do I do first here? 3 times negative 2, that's negative 6. Add 2, negative 4. So look what happened here. I'm going to make another column. And I'm going to call this column x, y. Okay? What's my x value here? What's my x value? What's my x value?
Minus 2.
Negative 2. Where did I get the y value?
Minus 4.
Negative 4. So when I plug in negative 2 into the equation, the y value turned out to be negative 4. Okay, yeah. Where did I get the negative 4 from?
No, I'm okay now.
We're okay?
Yeah.
Do we know where we got the negative 4 from? That says I have to do the multiplication first, right? So I have to multiply the 3 times the negative 2. That gives me negative 6. If I add 2 to negative 6, it's going to get me to negative 4. How about for the second one? So y equals what? 3 times negative 1 plus 2. So, just a quick reminder that whatever, this is where x is, I'm going to place x with these different x values. Okay? So, 3 times negative 1, negative 3, add 2, negative 1. So, in this case, it turned out to be the same. X is negative 1, y is negative. Okay. Y equals 3 times what? Plus 2. 3 times 0 is 0. Add 2. 2. So your point is going to be 0, 0, comma 2. Okay, next. 3 times 1 plus 2. 3 plus 2 is 5. So remember, 3 times 1 is 3, add 2 is 5. So my point is 1, 5. And then my next one is 3 times 2 plus 2. 3 times 2 is 6, add 2 is 8. So my point is going to be 2, 8. Okay? So you see now I have 5 points that I can put on my graph. They should be a straight line. If they're not a straight line, then I've done something wrong. Okay? So let's start with the first point. Negative 2, negative 4. So, eyes on me please. You're going to start on the x. So on the x, negative 2 is right here. And because my y value is negative 4, I have to go down to the negative 4. Okay? So 2, negative 4. So my point is going to be here. Are we okay with that? So x is negative 2 and y is negative 4. So negative 2 and negative 4. This is where my point is. How about my next point? Negative 1 and negative 1. So I'm going to go negative 1 on the x, negative 1 on the y. And they meet not here. So negative 1 and negative 1. So they meet right here. 0, 2. It goes on the 2, which 2? On the y, right? So 0 is right here. 2, so I'm going to go up 2. So this is where the point is. What do we call that point? The y-intercept. Then I have 1 on the x, 5 on the y, 1 and 5. They meet right here. The next point, I don't have an 8 on the y-axis, so I can't draw it. But this is more than enough for me to actually draw my straight line. So I can actually go and join these lines together, extend it a little bit, and then put my arrows for that straight line. Okay? So you need to know where to locate your points. Okay? So I can either find the x-intercept and the y-intercept and graph, or I can make a table of value and graph the points. Now, you can pick any x values. In this case, they told me what x values to pick. You can actually pick any x values that you want. These are the easier ones, okay? -2, -1, 0, 1, and 2. These are the easier ones, but you can pick any x values. Are you guys okay with this? Because we're getting to the harder one. Okay. Well, I don't personally find it the harder one, but it just has more steps. Okay. Now, the third step, or the third way, you have to have it in what we call the slope y-intercept form. So, remember we talked earlier that if you have y equals, or not y equals, sorry, my apologies. If you have ax plus by plus c equals 0, that means it's a linear function, right? We talked about that. We said this could be one format. The other format is if I have y by itself, so y equals, and I have something x, we call it mx, plus b. Okay? So eyes on me for a second. This, for example, if I have y equals 2x plus 3, that's one way, one example. Or if you have y equals -1 over 2x minus 3. Okay? That's another example. So you see y by itself, then you see a number x plus or minus another number. Okay? We call this format slope y-intercept form. Does anyone know why we call it slope y-intercept form? M is the slope. So whatever is with the x, that's your slope. B is the y-intercept. Okay? The reason why we call it slope y-intercept form is because it's easy to find the slope and it's easy to find the y-intercept from. Okay? So your idea is to keep y by itself, move everything else to the other side. Okay? And then whatever is with the x is your slope, and the other number is your y-intercept. Okay? So slope here is 2, y-intercept is 3. Do you guys know what a slope is? What do you say?
I just heard someone say that.
What do you say? Rise over run, right? Which means it's your steepness. It's the steepness of your line. Okay? So how steep is your line? How much are you going up versus how much are you going over? Okay? We're going to talk more about that. What's your slope in the second equation? Y equals -1/2 x minus 3. What's your slope? -1 over 2. What's your y-intercept? -3. Okay. So, first of all, if the equation is not already in slope y-intercept form, you're going to have to rearrange that equation. Okay? So you're going to have to rearrange the equation so it looks like this. Where m is the slope and b is the y-intercept. y-intercept first, and then you're gonna have to use your slope, which is rise over run, to complete the graph. I'll show you how. This is just filling in the blank for now. I'll show you how we're gonna do that. So first of all, this is an equation. So I have 3x plus 2y equals 4. I want to write it in slope y-intercept form. So I want y by itself, everything else to the other side. Okay? So I'm going to have to keep y on this side, and I'm going to have to move the 3x over. 3x is positive. When I move it over, what happens to it? Negative, because the opposite of positive is negative, subtraction. So 2y equals negative 3x plus 4. Okay? So this is going to come here, it's going to become a negative, and then the plus 4 is going to stay there. Is y by itself or not yet?
No.
Not yet. I have a 2 with it. What do I do to move the 2 over? Divide by 2, right? Because I want to get rid of this 2. There is a multiplication here. When I bring the 2 over, it's going to become a division. So what I want you to do for this, I want you to divide each term by 2, so you don't mess it up. Okay? You're going to divide each term on the right-hand side by 2. Okay? Because the opposite of multiplication is division, right? When I bring that 2 over, it's going to become a division by 2.
That is separate.
Yes, because you want to have, like, you want to be able to simplify this if you can, and you want to have your slope by itself. Okay? So, this is, the negative 3 over 2 cannot simplify, so it's going to stay negative 3 over 2, right? I can't simplify this, right? It's going to become a decimal, so I'm going to leave it as a fraction. You'll see why. And then what's 4 over 2? 2, so plus 2. Let's look at this y equal negative 3 over 2x plus 2. Where does this look like this to you guys? Yeah? What's m? Which is negative 3 over 2, right? Which is your slope, right? You see how it's with the x? Okay, what's b? 2. Okay, so that means your y-intercept is 2, and your slope is negative 3 over 2.
That's all you have to do.
Yeah, so now it's written in a slope y-intercept form. Now we have to graph.
Can you flip that over? Thank you.
I'm gonna actually have to bring it down soon, so if you wanna write this, so I can bring it down. So the first thing you wanna do is you wanna plot your y-intercept. So I wanna place where my y-intercept is. So my y-intercept is y equals 2. Can I bring it down now? So the y-intercept is 2. Where do I put that? So on the vertical line or on the horizontal line? The vertical. So this is y, and y is equal to 2. So this is my y-intercept. Okay? So remember that my y-intercept is 2. Now, here's what I want you to pay attention. Put your pencils down and look at me. Slope is rise over run. So, just so you guys know, vertical, horizontal. Okay? If I'm talking rise, am I talking vertical or am I talking horizontal? horizontal. So, if I look at this, which is negative 3 over 2, that's my slope that I just got here. It's telling me that I have to rise by negative 3. What does it mean by rise negative 3?
From that point, go.
From that point, go which way? Down 3. Because you're rising negative, that means you're going down. Okay, so that means for this one I have to go down 3, and I'm talking from the y-intercept. That's why I put the y-intercept first. So I'm going to have to go down 3, and then to the right 2. Okay, so down 3, because it's negative, and then you always move to the right, and then to the right 2. Okay, so I'm at the y-intercept. I'm going to count 3 down, so 1, 2, 3. And I'm going to go to the right 2. So 1, 2, and I stop. This is where my stop is. It's like I'm telling you, go 3 blocks south and 2 blocks east. That's the same thing. Okay? That becomes your second point. Okay? So you see now, that's my second point, so I can erase this. Now, from that point, you're going to do the same thing. You're going to go down 3 to the right 2, and that will be your third point. Okay? So down 1, 2, 3, and then to the right 1, 2, and that's going to be my third point. You see that if now I join all these points together, I form what kind of line? A straight one. Okay? So I start with a y-intercept, and I use my slope to locate my next point. What if my slope was positive? Which way do I go? Up, and then to the right. Always to the right. Always to the right. Always to the right. Use that negative to go down, and then always to the right. So if you look at this, because the slope is negative, my line is going downward. If my slope is positive, my line is going to go upward. Okay? Just so you guys know. Okay? So these are the 3 different ways. Finding the xy intercept, the 2 points, and then joining them. You can do a table of values and finding the points, or you can put it in slope y-intercept form, which require you to do some math first if it's not already in that format, and then you can use your slope and y-intercept to graph. Okay? So here's what I want you to do. You have the next 2 pages. Okay? These explain, these are like different exercises that that you can practice all 3 different formats. Okay? So you guys can work on this. You can talk to other people.
Sorry, just one question.